Hello class, this is Mrs. Albritton of Albritton's Math class, AMC. This video we're going to be looking at the trigonometric ratios that we learned about in class. So before we start, let's go ahead and use that mnemonic device that we found out about that helps us to keep those ratios in mind. And it is SohCahToa. What does that mean? Well, let's take a look. We found out that there are 3 trigonometric ratios that we use to identify the sides of a right triangle. The first one is sine. And for example, if we're looking for the sine of some angle that we'll call theta, so we're asked for the sine of angle theta, then what we're looking for is the opposite side over the hypotenuse. Opposite over hypotenuse. For the CAH part of SohCahToa, we are looking for the cosine of some angle theta. So the cosine of an angle that we'll call theta means we're looking for the adjacent side of that angle over the hypotenuse. And then lastly, the TOA part, that's the tangent. So if we want the tangent of some angle that we'll call theta, we're looking for the opposite over the adjacent side. And that's how we come up with SohCahToa. And sometimes it's called, I hear people say SohCahToa. All right. So how does that work though? Let's find out. Take a look at problem number 1. Notice that we have a right triangle. How do I know we've got a right triangle? Because we have this right or 90-degree angle A right here. So that makes this a right triangle. Now we have 2 acute angles also, angle B and angle C. For this problem, we're going to find the sine, cosine, and tangent of angle B. And what that means is we have to keep in mind that we're looking for the sides from angle B's perspective. So when we're looking for the sine of B, and we know we need the opposite over the hypotenuse, we're looking from B's perspective, and the side that is opposite angle B is 16. So this is 16, the opposite over the hypotenuse. And remember, the hypotenuse is going to be the longest side of your right triangle, which is 34. So here is the ratio for the sine of angle B. Now, sometimes you'll be asked to write this as a decimal, round it to some place, maybe the 10th or the 100th place. Let's get the cosine for angle B, and that is adjacent over hypotenuse. So again, you're looking from angle B's perspective. Adjacent means beside. And right now we've got this side is beside angle B, and so is the hypotenuse. But the hypotenuse is it's a special case, all by itself. It's special. So the adjacent side from angle B is 30 over the hypotenuse of 34. There's the ratio for the cosine of angle B. Tangent of angle B, we're looking for the opposite over the adjacent. So again, the side opposite angle B is 16, and that adjacent side is 30. So those are the ratios for angle B. Let's do the same for angle C. So now instead of looking from angle B's perspective, we're looking from angle C's perspective. So when we want sine, which is opposite over hypotenuse. But if you're looking from angle C, the side that is opposite angle C is going to be this side, directly across from it, 30. So it's not 16 like this one was, because we're looking from a different angle. So it's 30 over the hypotenuse, that is still 34. The cosine of angle C is adjacent over hypotenuse. So here we have angle C, and the side that's adjacent to it is 16. We can't say 34 because that's the hypotenuse. So 16 is besides angle C, that's 16 over the hypotenuse of 34. And then lastly, for this problem, the tangent of angle C, opposite over adjacent. So the side that's opposite angle C is 30, adjacent is 16. Our ratio is 30 over 16. All right, and again, sometimes you may be asked to write those ratios as decimals. If you do, you can use your calculator and then round them in the position that you're asked to round it in. Okay? And then we're gonna look at problem number 2.